Hi, couple days ago I came across this one-liner game for Commodore 64, so I thought that we could take a look at it together, try to play it of course, try to analyze the code and see how does it work, and maybe even optimize it in the end. So the game is simply called Oneliner 64. It was written by Joe Progivers. I hope that I pronounced that correctly. I will put the link to his website in the description of this video so you can check it out yourself. So it's an arcade action game for Commodore 64 written in single line of basic code. Now, that sounds pretty amazing. Is that even possible? Well, let me type in the code so we can check it out together. Go E and 0 5. So here we go. This is the whole code for the game. As you can see, we use lots of abbreviations. So, and there is a good reason for that. We need to cramp as much as we can into single line of code, and we are limited by 80 characters max. So this is the only way that we can enter as much as we possibly can. So if I press return and then list, here we go. Now you can see full commands, and as you can see, we were able to enter more than 80 characters per one line of code in BASIC. The only downside is that this line is not editable now. I mean, it is editable, but we would lose this third line, of course, third row. So if we want to change anything, we have to re-enter all over again. So let's go and run the code and see what do we have, what kind of game this is. And here we go. We have letter V that should represent some kind of missile or something like that, and we are trying to avoid this cloud of asterisks and go right through them without colliding, of course. So this is the whole point of this game. Try to survive in this madness, and this is amazing. I mean, one line of code, and look, we have complete action game on our screen. Okay, I died, and we have undefined statement error in the end. So let's go one more time. So we are using keys 1 and 9. So 1 is to go left and 9 is to go right, and that's the only two actions that we can do. Here we go. Nice, isn't it? Yeah. So I really love this little snippets of code. Kind of reminds me of this basic waves and 10 print maze and stuff like that. This is why I absolutely adore Commodore 64 for this kind of things. Yeah, I don't think that you can do this on any other platform. I mean the modern platforms, right? this one line of code, and look at it. We are running like crazy. Yeah. Okay. So that's the game. Now let's jump to the editor and try to break this code down and analyze it and see what it does. How does it achieve this this functionality? So let's go. So here we have our code. This is original code from the author with the abbreviations, and we will get rid of those by convert them to all commands, so to make it more clear. And now we will break the code in several lines. So everywhere where we have semicolon, we will break them, create a new line. So from functional perspective, everything should work as before. So this is it. So this is the whole game, just 5 lines of code. So let us go line by line and see what is going on here. So on line number 1 we have print tab random number, and so we generate random number from 0 to 39, and we print asterisks. We print that many empty spaces, and then print asterisks. So what this line does is fill our screen with asterisks. Now let me switch to here, and let's see what this code does. And let's go to 1. So this will just repeat endlessly. Let's run it. So here we go. That piece of code generates these floating asterisks. Okay, so the second line is get k. So we are reading the keyboard buffer and storing that character into k variable, if there is any character stored in there. And this line number 3 is a clever way how to convert whatever key that we pressed into some numbers through which we can control this p variable. Okay, so let me break this even further. We are controlling this game by pressing keys 1 or 9. So 1 is for left, and 9 is for right. Okay, so moving right. So if we press if key k is 1, then we have a situation like this. So 1 is 1, this is it. And then what we have here, oops, sorry. Now if 1 is equal 1, this will result with -1. Okay, and then we have minus, and here 1 is equal 9, it's not, so this will result with 0. So this will give us p equals p minus 1. Okay, so that is if we press the key 1, so this is left movement, and this is exactly what will happen. So our p variable is position, position of that rocket, missile, or whatever it is, and it will go 1 position left. Okay, so if we press key number 9, so the 9 equals 1 and minus 9 equals 9, so we will have 9 equals 1 is not true, so this will be 0, and minus, and 9 is equal 9, so this result will be -1. And what will this give us is p plus 1. So it will be the right movement. So this is a clever way how to convert your pressed keys to the movement of some object on the screen, some parameters. Okay, so this is line number 3. Let me delete this. Now, line number 4 is simple poke command. So we are poking at position 1284 plus p, variable p, and this p offset is actually our movement. So we are moving either to negative or positive. So p is either negative or positive. So, and this position 1284 is, I believe, fifth road, somewhere in the middle of the fifth road, exactly. So with this plus p, we are moving right to that from the center or left from the center, and we are poking character number 22, and that is our, letter V. Yeah, so that's the V. Okay, now line number 5 says on P less than 420 and peak 1324 plus P equals 42 plus 2, then go to, then we are missing something, then we have comma 1. So this should be this is a little bit confused part, at least to me, because I don't know exactly what was intention to do here. I know what the author wanted to do. I'm just not sure why he did it in this way. Okay, so the whole idea of this line is to check whether our V letter is hitting the asterisk. So this equals 42 is a number for Pesky sign asterisk. This code is telling us if we hit asterisk, and then we should go to nothing, so we are done, and everything else is going to go to 1, so line 1, so we are going all over it again. This number, if p is less than 420, I'm not really sure why. I guess that 420 would lead you more than the screen memory. No, not really sure, but this line exactly is the line that we are going to try to improve and try to make it more shorter and make it more sensible. Also, we will have we can have some optimization here on line number 1. This is line number 2 is just fine. Line number 3 also fine. Here also there's nothing we can do here with this poke command. So let me just rewrite some lines here. So let me change, first of all, maybe just to get some speed, change 0 to dot. That's valid thing to do. Okay, we will leave the rest of it as it is, and this line number 5. All we want to do here is just to check if we are dealing with if we are hitting the asterisk or not. That's all. Everything else should just fit in place. We are very good with this p variable. We can move all over the screen. We can move across the screen, and so that's cool. We only need to fix this line number 5 because I don't understand why is this long. So all we need to do is if peak 1324 plus P is different from 42, then go to 1. So that should be it. So if we didn't hit asterisk, then we jump to line number 1 and continue looping. If we did hit, then this code will end. That's it. So let me delete this, and this should be our new simpler code. Let me bring this back to single line, and see, will it work? I hope it will. It should work. Let me and the next thing that we are going to do is we will use line number 0 instead of 1, and in that case we can remove this. It just says go to. That's it. So it will assume that we are going to line number 0. So here now I will make this. So print is going to be here. So we have tab, and then we have pen, then we have get key. Okay, then we have poke, then we have if, then we have peek, and then we have go to. So here we go. We abbreviated the code, and this is much shorter code. Now let's test it and see, does this code works or not. Okay, let me switch to Commodore 64. So this is our code. Let's list it. Yeah, here's this inside. Let's run it. And here we go. Yeah, working nice. I got them. Yeah, and it's perfect. Okay, we hit plastics again. We have to be careful, and we are going to hit this one as well. Like I said, no. Okay. So this is working. We optimized the code a little bit, and it works nicely. So, just one more thing. We can change sides. Yeah. You see, we came to the left side. We actually, not only that we switch sides, we switch. We come to the just one row below. If we go to the right, we are descending row by row. If we're going to the left, then we are going up row by row. Okay, so this is what I want to do. So the original code had 79 characters, right? Our new code has 67 characters. So we have a little bit more characters that we can use here. And that means that we can upgrade this game. Well, let's do that. So what we are going to do is try to add some colors, and we are going to place the color command. So we are going to color the V character, so this rocket missile, whatever it is, and place it here. So this is the poke command. This is the position, color position of this in memory, and the color we are going to use is 5. So we want to keep it with the single digit color. We cannot use Or maybe we could use 2-digit color. Okay, so with this we are back at 79 characters, so this should work. This should be now upgraded version of this game, which is amazing that we are able to upgrade the game that is made in single line of code. But okay, new code is entered. Let's run it. And the first one, yeah, great. And here we go. We have color. Yeah, this is so much better. This is great. Yeah. So, the only thing that we are actually missing here is a little bit of sound. If we had sound, this would be great. This would be just great. It's difficult. Yeah. Okay, so this is it. This is the game, and it's really, really fascinating. Yeah. Maybe add some scoring system. Be nice. But you know, in one line of code, this is more than amazing. The only thing that the original author said, it called this game Oneliner 64. I don't really like that game, so if you have any suggestion how to call this game, you can comment it down below. God damn it. Or if you have idea how to improve this game in one line, or maybe make it two-liner. Is there a category for two-liners? I know for 10-liner code, or one-liner, two-liner code, maybe? Yeah, I need to check that out. If you have any suggestion how to call this game, or is there any similar game already exists? I'm sure it does, on Commodore 64, comment it down below. And this is all for today. I hope that you enjoyed this little adventure in one-liner game that we had today. And all the code will be in the description of this video. So this is all for today, of course, and I hope to see you in the next one. Till then, goodbye.